Alrighty guys, welcome. We're doing Mod 7 review packet now. Here we go. I'm going to try to do every single question on this packet. I don't know if I'm going to make it, but we're going to try to do every single one. Here we go. So this very first question and all questions like it, you really just need to factor first and then look for cancellation. So factor, cancel, that's basically the general process for all of these. So factoring this guy right away, there's nothing to do on this top. But the bottom's going to factor nice and neat. Looks like we can pull out a 3x coming out of this. So 12x squared divided by 3x is going to be 4x plus 3. What cancels in this? Well, the 3's are completely gone. This x squared over x becomes a single x on top divided by 4x plus 3. Easy enough. Continuing on. So look for canceling best you can. So there are two ways to do these questions that are of this nature. You can multiply through the entire top, or you can cancel immediately. So I'm going to cancel immediately first. I'm going to try to do this question twice. Once where I cancel immediately first, and the other one where I cancel afterwards. So canceling immediately, looks like I have a 7, and this 21 can become a 3. This x to the 4th can become an x cubed if I take away this x. And this y to the 3rd is gone, and this guy becomes a y squared. So multiplying it out now is all we have to do. So we have x cubed times x to the 7th there, 2x to the 10th, divided by, and now on the bottom we got 5 times 3 is 15 y cubed. But instead, like I said, you could multiply through right away. So if I multiplied through right away, I'd have 14 x to the 11th y cubed divided by 5 times 21 is 105 x y to the 6th power. And now I have to start canceling. And this is kind of why I don't like doing it this way, is because now when I have to cancel this, I really got to do more thinking. It turns out that 105 is divisible by 7. Specifically, if I divide both of these by 7, cancel, this becomes a 2, this becomes a 15. 11 minus 1 is 10, so I got 2x to the 10th. 6 minus 3 is 3. Either way, you get the same answer. I'm going to box this one because I think it's easier to do the canceling first. This question over here, we have factoring, and we have to go ahead and split it up into 2. So splitting it up into 2, or sorry, I want to say splitting up into 2. So already split up into 2. We have to do the division. Division means multiplying by reciprocal. So factoring, this guy factor is going to be 3 times x minus 1. This factoring here is 2x multiplied by x minus 6. This is going to be x minus 6 times x minus 1. Multiplied by, we have to flip this upside down, 3 x minus 1 divided by 2x. 2x completely gone. X minus 1's gone. X minus 6 gone. Only thing left is that 3. Do all of them this way. This guy here, a couple different ways to factor this. I'll show this one the way that I taught in class, and then this one up here, you got to notice a trick, because that is square and that is square, so you immediately take a guess to see if it's 2x plus 3 multiplied by 2x plus 3. And this will work out. If I FOIL this back out, I will get back up to here, so it's a nice, easy little way of doing that question, is noticing that the top is just a square there and a square there. Divided by x minus 2, multiplying up here, x minus 2 times x plus 2. Now this guy, we have to factor this one separately. I'm going to do it up here because I don't really have enough room right where I'm at. So I'm going to 2x squared plus 7x plus 6. To do this question, we're going to go ahead and do 6 times 2. 6 times 2 is going to give us 12. That's 2 times 6, where I got those two numbers from. Now I'm thinking what multiplies to 12 and adds to 7. In this case, 4 and 3. We're going to split the 7x into the 4 and 3. 2x squared plus 4x plus 3x plus 6. Squiggly line. Factor out a 2x from the left 2. Factor out a 3 from the right 2. And that's going to factor into 2x plus 3 times x plus 2. The 2x plus 3 comes from there. The x plus 2 is right there. Go ahead and put it right here on the bottom. 2x plus 3 times x plus 2. Cancel everywhere you can. X minus 2's gone. X plus 2's gone. 2x plus 3's gone. Only thing left is this 1, 2x plus 3. This guy's a pretty fast one. I don't really know why this is here. We got x minus 2 divided by x plus 3 times x minus 2. Cancels completely. We get 1 divided by x plus 3. Pretty quick. This one looks long. It's really not that big a deal. Remember, dividing means multiplying by reciprocal, so 1 over that guy. Factoring out this x times x plus 11, all divided by x plus 3, multiplied by 1 over 3x times x plus 2 times, that's difference of two squares, minus 3 plus 3 over x plus 11. Cancel. Cancel. Anything else canceling? Oh yes, x's go away too. So what's on top left over is just x minus 3. What's left over on bottom is 3 times x plus 2. Nice. Solving rational equations. So remember, your goal here is to multiply through by the common denominator to get rid of denominators. The easiest way to do this is to start off by writing that LCD. The LCD in this question is going to be 2x. And then you ask yourself over and over, what is this 4 over x missing? That 4 over x is missing a 2, so I put it right there. This 2, what is it missing? It's missing an x, so 5 times x. Again, it's that numerator times what's missing. Equals negative 11. What is this missing? A 2. Solve like a regular old problem. 8 plus 5x equals negative 22. 5x equals negative 30. X equals negative 6. Same process on these questions. Least common denominator in this problem is going to be 15. This x plus 6 is missing nothing, whereas this 2 over 3, that guy's missing a 5. So x equals, that's 10 minus 6 is 4. Over here, number 9. So again, same exact stuff we've been doing. Least common denominator in this case, LCD, is 6 times 7, which is 42. This x plus 8 is missing a 7. This x minus 3 is missing a 6. Solve. 7x plus 56 equals 6x minus 18. X equals negative 74. I feel like I did that question in class once. I don't remember though. And the last couple, let's do them. LCD, boom, right away. LCD is 12. Multiply through by 12. If you multiply through by 12, we are going to be asking ourselves what is missing from every single step. What's missing in this is going to be a times 2. What's missing here is going to be a times 4. Nothing's missing on the right. Solve. 2x plus 2 plus 4x equals x. So that 6x subtracted over is negative 5x. 2 over negative 5 equals x. Negative 2/5. Keep it coming. Multiply through, we got LCD, 5x. What's this guy missing? X plus 1 is missing a 5. 7 over 5, what's that missing is an x. Solve. 5x plus 5 equals 7x. 5 equals 2x. 5 halves is x. 2.5. Last one on this front page. Least common denominator is x minus 2. 5x equals 7 multiplied by x minus 2 plus 10. Solve. 5x equals 7x minus 14 plus 10. Negative 2x equals negative 4. X equals positive 2. Not that big a deal. Let's go to that second page. More of the same. So some of these got to factor first. So like this guy here factors into x times x minus 1. In fact, that is our LCD. x times x minus 1. Now we got to ask ourselves what's each one missing. This 2 is missing nothing. This 1 is missing an x. And that's it. 2 equals x. Done. Nice. So this whole time it has been checking for extraneous solutions. Did I do that on the other page? Did I have any oopsie pies? Oh boy. Look at this number 12. I had big oopsie pies on number 12 here. X equals 2 cannot be a solution. There's no solution here. No solution. Oh my. What a disaster. No solution. Can't happen. X can't be 2. Why is X not allowed to be 2? Well, if I plug 2 in the original equation, I'd have 10 divided by 0. That's not good. No good at all. Cross that off. No solution allowed to this problem. Sorry about that, guys. I wasn't checking for my extraneous solutions there. So like on this problem, X would not be allowed to be 0. I don't think it's going to be 0, but LCD is X, and we got 3 plus X times X equals 4X. So 3 plus X squared equals 4X. X squared minus 4x plus 3 equals 0. X minus 3 times x minus 1 equals 0. X equals 3 and 1. Not too bad. This guy here, LCD, 3 times x plus 6. This 2 is missing an x plus 6. This 2 is missing an x and an x plus 6. And this 8 is missing a 3x. 2x plus 12 plus 2x squared plus 12x equals 24x. Move everything to the left. 2x squared. We got, what is that, 14x. 24 minus 10x plus 12 equals 0. Factor 2x squared minus 5x plus 6 equals 0. 2 times x minus 3 times x minus 2 equals 0, and x equals 3 and 2. Keep it coming. Number 16, LCD, immediately. LCD is going to be equal to x multiplied by x minus 4. X minus 3 here, it is missing an x. This 4, it's missing an x and an x minus 4. This 3x is missing an x minus 4. I'm going to run out of room. I'm going to draw like a little line for myself. Oh boy. It's going to be a little bit ugly. Should have moved it to the left earlier. Whoops. X squared minus 3x plus 4x squared minus 16x equals 3x squared minus 12x. Oof, that is not easily read. Apologize about that. Again, I'm going to move left. I said that earlier and I just didn't do it. Okay, so we have x squared and 4x squared is 5x squared minus 3x squared is 2x squared. Negative 3x minus 16 is negative 19x. Negative 19x and plus 12x is minus 7x equals 0. Factor x multiplied by 2x minus 7 equals 0. So x equals 0 and 2x minus 7 equals 0. So 2x equals 7, x equals 7 over 2. So we have two answers, but check for those solutions because I can't have 0 as an answer. If I had 0 as an answer here, disaster. So that's not a correct solution. Only 7 over 2 works. Please note, I'm silly. I didn't check one of the tricks I was telling you guys to do right at the start. You got to look to see if you can cancel. I could have canceled these x's out immediately, and the question would have been a lot easier. I don't know why I didn't do that. It was just bad decision making on my part. I got no excuses for myself other than bad decision making. So this one, let's factor that numerator first because it looks like we can actually do some canceling right away. You don't have to do this step, but you know, it can make life easier. 2 times x plus 7 divided by x plus 4 minus 2 equals 2 times x plus 10 divided by 2 times x plus 4. And here's what I'm talking about. The 2's cancel. Nice. LCD now. LCD is just x plus 4. So we got 2x plus 7 minus 2 times x plus 4 equals x plus 10. Again, I'm dividing this up because I'm going to run out of room if I don't. 2x plus 14 minus 2x minus 8 equals x plus 10. So we got 2x minus 2x, that's gone. So we got 14 minus 8 is 6. Subtract 10, negative 4 equals x. Check your work. Does negative 4 work? Oh, negative 4 cannot possibly be a solution to this problem because I divide by 0. No solution. Move on to number 18. So number 18, LCD. X minus 1 multiplied by x plus 1. This negative 3 is missing an x minus 1. This 4 is missing an x plus 1. Negative 3x plus 3 equals 4x plus 4. We get negative 1 equals 7x, so negative 1/7 equals x. Easy. Finishing this guy up, number 19. Now we have lots of room all of a sudden. Hilarious. Again, look for factoring if you can. You don't have to factor out this 8, but it might end up being a good thing. You never know. This guy factors into x minus 2, x plus 2. Nothing changes on the right-hand side. LCD is going to be x minus 2 times x plus 2. This guy's missing nothing. So actually that factoring didn't help us, but sometimes it does. Finishing it off, 8x minus 8 equals 4x plus 8. 4x equals 16, and therefore x equals 4. Is x allowed to be 4? It sure is. We're good to go. The next problem here, I'm just going to divide this early. There we go. Factor, we got 2x over x minus 3 equals 3x over x plus 3 times x minus 3 plus 2. LCD is x plus 3 times x minus 3. This 2x is missing an x plus 3. 3x plus, and this is missing everything. So I'm going to write this here, 2 times x squared minus 9. What I did was I multiplied these in advance. If you multiply these in advance, your life can be a little bit easier. The reason why I can multiply those so fast is I notice it's just like a difference of 2 squares. Difference of 2 squares, difference of 2 squares. Not too easy, not too bad, not too hard. What am I saying? Not too easy. It was easy. 2x squared plus 6x equals 3x plus 2x squared minus 18. 2x squareds are gone. 6x minus 3x is 3x equals negative 18. And x equals negative 6. Can you be negative 6? You sure can. All done. LCD in this very last question is going to be 30. I remember this question in the homework somewhere. I think we already did this question, but that's okay. LCD is 30. So what is that 5 missing? The 5 is missing the times 6 plus 4x plus 1. That's missing a times 5. 5x is missing a 10. Just got to solve. 12x minus 18 plus 20x plus 5 equals 50x. So negative 18 and 5 is negative 13. 50x minus 32 is 18x. Negative 13 over 18 equals x. I'm like virtually certain we did that one in class, but whatever. All right, moving on. Oh, we have the big review section, end behavior. Okay, so starting off, as x increases without bound, as x decreases, typo, that's the same thing as x approaches infinity, you know, as x approaches negative infinity. And remember, these things mean the horizontal asymptote, if there is one. So if there is a horizontal asymptote in these questions, then that's the answer to these problems. And here, there is a horizontal asymptote. Why? Got to remember those rules that we had in my last video. Please go check out the entire last video if you need a review on horizontal asymptotes, that 7.1 to 7.3 review. I have a huge spiel about how to figure out horizontal asymptotes. But in this question, we're doing negative x over x, which is negative 1, that leading degree over leading degree. So f of x equals negative 1, f of x equals negative 1. Apparently, some teachers are requiring on this if it's above -1 or below -1. If your teacher's requiring that, come talk to me and I'll help you out with that. But I'm not gonna do it for my class here. It's not a requirement. So as x approaches -1 from values less than -1, so it's saying, okay, we have this vertical asymptote here. So you have a couple options. You could sketch this, if you really wanted to. I don't think that we need to really sketch it. We can just ask ourselves, all right, what happens if I were to plug in a number less than -1? That is to say, on the left-hand side of -1. So x approaches -1 from the left-hand side, and this guy's x approaches -1 from the right-hand side. Please note, this question in some ways is a little bit poorly designed. I wouldn't have written this question myself this way. The reason why is that these -1s are not these -1s. These are y values. This is a y equals. These are x values, and this y value occurs because of the horizontal asymptote. These x values occur because the denominator equals 0 at these vertical asymptotes. Anyways, these vertical asymptotes, the only options are positive infinity and negative infinity. So you want to write that down. Vertical asymptote always goes, this behavior here is always plus or minus infinity. It's one of the two. So if you're ever confused, you have no idea what to do on a test, just put one of the two, get a 50-50 shot of getting it right. Might as well have a chance. Anyways, on the left-hand side of -1, left of -1 is -1.0001 or something like that. If I were to plug that number into this function, that is to say f of -1.0001, that's going to give me 9 plus 1.0001 divided by -1.0001 plus 1, which is going to be 10.0001 divided by -0.0001. So it's going to be a negative number because of that negative sign. Therefore, this must be negative infinity. And likewise, you could do the same process. You'll get positive infinity for this answer if you went through it. Another way of thinking about it, I don't have another good way for right now. You really just got to think, is it going to be a positive number or a negative number? That's going to be your key. So like on the greater than x would be like -0.999, by the way. Either way, you will get a positive number if you do it this way. A number less than 1 plus 1 like this is going to be positive 1. I shouldn't have said less than. I should have said smaller in absolute value. Anyways, these numbers are always going to be different. One's negative and one's positive whenever you have an odd multiplicity like this, x plus 1 to the 1. Whereas in this question here, you have this x minus 3 quantity squared, so they're actually both going to be the same number. In fact, this problem, everything ends up being squared, so it's going to be positive everywhere. So I don't really have to think about this too much. It has to be positive infinity on both of these, but if you wanted to go through this process again and actually plug in numbers, you can. Not that big a deal. As x approaches infinity, as x approaches negative infinity, again, it's that horizontal asymptote. So in this question, we're checking 3x squared over x squared, which goes to 3, so we got 3. 24, what are 3 other terms that can be used for roots of the function? Well, x-intercepts and zeros. I don't know the third one, but I am assuming that they're talking about solutions. When they're talking about solutions to something, it usually means setting it equal to 0. We haven't used that word too much in class. I'm much more worried about these two. If this word shows up on the test, the solutions, I'll probably just remind people of it. But yeah, I bet you that's what they're looking for. Explain how you can find the following: the horizontal intercepts of a rational function. So the horizontal intercepts, maybe that's what they wanted. X-intercepts, horizontal intercepts. I don't know. Horizontal intercepts, that works too. Anyways, this one we want numerator equals 0. If we set the numerator equal to 0 in this question, that is the top part of it equal to 0, you'll find the horizontal intercept. The vertical intercepts, plug in 0. That's easy. It's always going to be 0 comma some y value. You just plug in 0, see what you get. Horizontal asymptotes, explain how you do it. Check out my last video. Check out last video. You got to compare those degrees. The degrees I'm talking about, you got to do degree of numerator, degree of denominator, see what happens. Like we were doing it up here on these questions. They were the same, so we looked at the coefficients. But if they're if the bottom is bigger than the top, it goes to 0. If the top is bigger than the bottom, there isn't a horizontal asymptote, and you have to go back to last chapter. Not worried about it. Vertical asymptote is denominator equals 0. There's a big warning for both this guy and this guy. Except at holes. Except at holes. So if the top and bottom both cancel out with each other, neither of these apply anymore. So you got to be checking for holes first before you do these steps. Next page. Boom. It's the last page? Last page? Oh, nope, we got more than that. Oh boy. We got 2 more pages. It's okay. We're going to make it through, guys. We're going to power through. For each of the following functions, find the horizontal and vertical asymptotes or holes and the horizontal vertical intercept. So it wants us to do all the things from that previous page. So I personally like starting with the roots. So the roots, that is the horizontal intercepts. So that's going to be setting 2x plus 1 equal to 0. So subtract 1, divide by 2. I'll get x equals negative 1/2. And I guess if they really want the horizontal intercept, the fancier way of writing this would be, you know, negative 1/2 comma 0, but whatever. The next guy, the vertical intercepts. So our vertical intercept are 0 comma whatever in this question. If you plugged in 0, you'll get 1 divided by negative 5. There's really not much to it. 0 comma negative 1/5. Horizontal asymptote. In this question, the horizontal asymptote can easily be found by comparing 2x over x. You simply get y equals 2. And your vertical asymptote, hopefully it's obvious, but x equals 5. Setting that denominator equal to 0. 27, you got to factor first. X minus 1 times x plus 1. Roots. Well, the numerator is 5. That does not equal 0, so there are none. No roots. The vertical intercept, that 0 comma question mark in this problem, if you plugged in 0, you get negative 5. Horizontal asymptote, there's no x at all in the numerator, so it's got to be y equals 0. That denominator has a larger degree than the numerator. And then the vertical asymptote in this question is both x equals positive 1 and x equals negative 1. Keep it coming. This guy factors into x times x squared minus 4. Don't stop factoring. It factors more. X multiplied by x plus 2 times x minus 2. Because there's an x plus 2 on the top and an x plus 2 on the bottom, they cancel. Oh, these had no holes, by the way. None. Holes. None. Here, we're going to get 1 on top now because the x plus 2 cancels. And here, we're going to have x multiplied by x minus 2. And this is really the function we're working with here. We have a hole right away. A hole at x equals negative 2. X equals negative 2 because we canceled out that plus 2. Those went away, so we get that hole there. You could be a little bit fancier about it if you wanted to. This isn't really a requirement, but you can actually figure out the coordinate of the hole if you wanted to by plugging negative 2 into the new result here. If you do that, you'll have 1 over negative 2 times negative 4. You'll get 1/8 positive. After that, we're going to go ahead and look for our roots. We don't have any roots in this question. That 1 never equals 0. And sorry about that. Light turned on and off. We got none here. After that, we have the 0 comma whatever. If you plug in 0 to this function, comma whatever, you get error. Can't do it. You can't divide by 0, so none. If you plugged in a 0 here, you divide by 0. What that means is our vertical asymptote, which we're going to do in just a moment, our vertical asymptote certainly has x equals 0 as a result. So if vertical asymptote is x equals 0, you can't have a vertical intercept. It happens sometimes. So x equals 0 is a vertical asymptote. X equals 2 is. A horizontal asymptote, there is no x in the numerator. Or you could look at the original x cubed over x. Regardless, you will get y equals 0 as your horizontal asymptote. 29. Now we're actually graphing this, guy. So we got to find those asymptotes and intercepts and stating domains and all that good stuff. Step 1 is always factoring. X minus 5 times x plus 4 divided by, and this is going to be x minus 5 times x plus 2. So these guys cancel out. And we're just going to get x plus 4 over x plus 2. And that's really what we're graphing. So we have a whole at x equals 5. And again, you could plug 5 in up here and you get 9 divided by 7, but I don't really care. All right, asymptotes. So we have a vertical asymptote at x equals -2. We have a horizontal asymptote. X over x is 1, so y equals 1. Our intercept, we have x equals -4 as a root, an x-intercept, because the numerator equals 0 there, so we can write that as -4 comma 0 if we want. And if our x value equals 0, we plug in 0 to the function, we get 4 divided by 2. 4 divided by 2 is 2. So let's start graphing this up. You don't have to do this. I just like doing these little tick marks. Makes me happy. Okay. So -4 comma 0, there's a coordinate. 0 comma 2, that's a coordinate. Vertical asymptote at x equals -2. Horizontal asymptote at y equals 1. Remember, this only happens after the last 0 or asymptote. So we have 1 after this 0 here, 1 after this asymptote here. And again, pure logic for answering these questions. You start off, you have to approach asymptotes. So one thing that I noticed when I was grading those quizzes from last time is some people just didn't approach the asymptote. They had lines going up here. You have to approach an asymptote on either side. It has to approach an asymptote somewhere. So if you drew your asymptote and then you don't approach it, you're like wasting your time. Like you should be approaching your asymptote. So you're approaching from either the top or the bottom, but you know it has to be the top. 2 reasons. First of all, it's got to go through that coordinate, and you can't cross these lines. The second reason is if I started here, I have nowhere to go. I can't cross this. I can't cross the x-axis because I'm only crossing the x-axis at my intercept that I already wrote up here, this -4. That's guys over here. And yeah, it's just not over there, so it's up here. And again, it flip-flops all the way down to the bottom now. And got to go all the way up here. Remember, the only time it doesn't flip-flop like that is when you have a squared on it. That x plus 2, if that was squared, it would not flip-flop. Please note, if you've already graphed it up, that as x approaches -2 from the right-hand side, by the way, this isn't required, I'm just doing extra. As x approaches -2 from the right and x approaches -2 from the left, this is a really, really easy question now. Because on the right-hand side of -2, it is clearly positive infinity, and on the left-hand side of -2, it is clearly negative infinity. So if you graph these first, it's a lot easier. I almost forgot my hole, but I didn't forget. I am so proud of myself. So there's a hole right there at x equals 5. You just kind of got to put a hole on it right there. It's really ugly, but maybe just mark it hole. Okay, great. Probably should not have put an arrow like a graph. Life goes on. Domain. X. Okay, I started writing it like a fancy stuff. How about x is any real number except x cannot be what is x not allowed to be? Well, it can't be a whole, so x cannot be 5, and x cannot be where's the vertical asymptote? -2. You can't divide by 0. So maybe a better way of writing this would be, I like writing ARN, that stands for all real numbers, comma, x is not equal to 5 or -2. And if you want to be ultimately fancy, you want to write it the fanciest way possible, you go little bracket, x is an element of the real numbers such that x is not equal to 5 or -2. I don't really care what you write. There's also another way. Some teachers do it like what numbers could it be on like a number line kind of thing. So it could be negative infinity, comma -2 union -2 comma 5 union 5 comma infinity. That is also correct, but English ARN, but except not, fancy ways. Whatever makes you happy, it's not that big a deal. Number 30, keep it coming. So factor that numerator, 4x multiplied by x plus 3. Factor this denominator, x plus 3 times x plus 1. Lots of nice canceling there. So this guy ends up becoming 4x over x plus 1. So we have a whole at x equals -3. We have asymptotes. We have a vertical asymptote at x equals -1. Horizontal asymptote, denominator equals 0. Horizontal asymptote, we got to do 4x over x. So y equals 4. Our intercepts, numerator equals 0 at 0. So we actually get 0, 0. And funny enough, this is both x and y intercepts. It is the root and it is the vertical intercept, both, because they're both 0. Easy enough. That happens sometimes. So we got the 0, 0 coming down. Got to start making my tick marks. I'm going to kind of scoot up here. Where was I? I'm like losing track of myself here. Taking too long doing things. All right, x equals -1. We have a vertical asymptote. We also have a horizontal asymptote at y equals 4, only after the last 0 are asymptote, so it's going to go over here. There's your y equals 4, and over here. So it could cross right there, but we don't actually know what happens. And we just got to use logic. So if it starts up here, I'd have to like go around and through here and go back. That can't happen, so I must start below, approaching the asymptote, and it's, again, got to go through that. So maybe that's another way of thinking about it for yourself. If you're really struggling with where these things go, you could always just plug in a value. Let me give you an example. If I were to plug in, for instance, I don't know where it goes, here or here. I can't figure it out. If I plug in -3 into this function here, I could actually figure out if it goes up here or down here just by figuring out the result of plugging in -3. So if I plug in -3, I'll get 4 multiplied by -3. I'm using this right here. Divided by -3 plus 1. That's -12 over -2, and that's 6. So I have this coordinate -3, 6 that I can use. -3, 6 is right there. Ah, now I know it must be up there. You can use this for every question if you like, by the way. Not a requirement. By the way, now we can do this again one more time. We don't have to do this, but I like doing a little bit of extra here. As x approaches, in this case, -1 from the right-hand side, as x approaches -1 from the left-hand side, g of x in this problem is going to be on the right-hand side of x equals -1. It is obviously negative infinity, and on the left-hand side, it's obviously positive infinity. So don't just like think positive, positive, negative, negative. It doesn't work that way. This is a positive and then a negative and a negative, then a positive. Be careful. Here, I'm just going to write that one most students like. All real numbers, x is not equal to -3 the whole, which I haven't graphed yet, and -1. So, oh, look at this. -3 was the whole. Beautiful. Now I know exactly where the hole is. Oh, man. What are the odds? What are the odds of that? Was not planned. Magic happens sometimes, guys. Magic happens. All right, last couple of questions. Use long division. I'm not a fan of long division, so I just gonna do synthetic division. So there's my synthetic division up here. Don't forget to pay attention to the domain. I don't know what that's all about, but whatever. Synthetic division here. We got -1 in the box. That's what makes this equal to 0. Then we got 4, we got 5, we got 2. We have 0. -1, we got 0 because there's a 0x. You've got to be careful there. Don't forget. 4 comes down. -1 times 4 is -4. 5 minus 4 is 1. -1 times 1 is -1, add, -1 times 1 is -1, add, -1 times -1 is 1, add it up, you get 0. So rewriting this expression, that is the remainder, constant term, x squared, x cubed, 4x cubed plus x squared plus x minus 1 plus 0. Bada bing, bada boom. I guess I'll do one long division question. So, which one am I going to do? Which is the hardest one? Actually, this one is the hardest one, so I'm just not going to do these last two. I said I was going to do all the problems, but I just don't like long division, so I don't feel like it. X squared plus 5, big division symbol. Write these in the correct order. X cubed plus 8x squared minus 3x plus 16. And if you're doing this, what multiplies up to x cubed from x squared is going to be an x. Multiply this x here. X cubed, x times 5 is 5x. Change the signs. We get 3x squared minus 3x. Complete the process. X squared times what is 3x squared? That's going to be plus 3. Oh, don't forget to bring the 16 down. Whoops. 3 times x squared. 3 times 5 is 15. So make sure you put it in the right spot here. Oh my gosh. I'm getting 0 points, guys. This is why I hate long division. I screwed up everything and now I have to restart. Here's my error. I had x squared and an x, and I tried to add them up. You cannot do that. That is such a big boo-boo. That is so bad. I was really bad, guys. I apologize. We're just going to restart this question. We're going to restart it down here. Okay. X squared plus 5, big division symbol. X cubed plus 8x squared minus 3x plus 16. X squared, x cubed, x again. This stuff is all going to be the same. I almost did it again. Plus 5x. 5x goes under the x, guys. Change the signs. So we got 0 here. We have 8x squared there. We have negative 8x there. Plus 16. What multiplies there is plus 8. 8 times x squared is 8x squared. 8 times 5 is 40. Change the sign. 0 minus 8x minus 24. This can't be divided, so my final answer is going to be x plus 8. Got that from up here. Plus negative 8x minus 24 divided by x squared plus 5. That's our remainder term down there. Almost got this off the page. Not too bad. I think I went too fast on this one up here, so I'm going to explain it one more time just in case. So negative 1 goes up in the box. 4 came from here. 5 came from here. 2 came from here. 0x minus 1. 4 comes down. Negative 1 times 4 is negative 4. Add. Negative 1 times 1 is negative 1. Add. Negative 1 times 1. Negative 1. Add. Negative 1 times negative 1 is 1. Add 0. Constant remainder. Constant term x, x squared, x cubed. Wrote it out. That's the whole review packet, guys. Hopefully that was informative. Good luck on this test Friday.